Pydantic AI's capability system is the mechanism through which agent behavior is extended via reusable, composable units. And within that system, the ordering of hooks determines which layer sees a request first and which sees the final result last. The hook's capability accepts an ordering parameter via capability ordering to declare its position in the middleware stack, either as the outermost layer or relative to specific other hooks. What follows demonstrates how two hook instances are configured, one positioned outermost and the other explicitly wrapped by it, then combined through CombinedCapability, which topologically sorts the list at construction time so that the declared constraints resolve into a predictable capability order. From Pydantic AI, capabilities import capability ordering, CombinedCapability, hooks. Logging hooks equals hooks ordering equals capability ordering position equals outermost. Rate limit hooks equals hooks ordering equals capability ordering wrapped by equals logging hooks. Hash logging hooks ends up outermost. Rate limit hooks is wrapped by it. Combined capability rate limit hooks, logging hooks. Assert combined, capabilities 0 is logging hooks. Assert combined, capabilities 1 is rate limit hooks. This composes two hooks capabilities using capability ordering to enforce nesting without subclassing. Logging hooks declares itself outermost, while rate limit hooks declares it is wrapped by logging hooks, so CombinedCapability topologically sorts them accordingly. The resulting CombinedCapability has logging hooks as the first entry, meaning its wrap hooks wrap rate limit hooks hooks. The pattern avoids subclassing AbstractCapability when you only need ordering constraints on lifecycle hooks. Trade-off is you lose fine-grained control over individual hook methods, but for cross-cutting concerns like logging wrapping rate limiting, this declarative approach is cleaner. The assertions verify CombinedCapability respects the declared ordering at construction time. Let's break it down line by line. From Pydantic AI, capabilities import capability ordering, CombinedCapability, hooks. Imports capability ordering, CombinedCapability, and hooks from the Pydantic AI capabilities module for use in agent behavior composition and lifecycle hook management. Logging hooks equals hooks ordering equals capability ordering position equals outermost. Creates a hooks capability configured to position its hooks outermost in the execution ordering. Rate limit hooks equals hooks ordering equals capability ordering wrapped by equals logging hooks. Creates a hooks instance named rate limit hooks with an ordering that wraps logging hooks via capability ordering. Hash logging hooks ends up outermost. Rate limit hooks is wrapped by it. Combined capability rate limit hooks, logging hooks. Combines two capabilities into one, passing rate limit hooks first and logging hooks second, so that logging hooks wraps rate limit hooks. Assert combined, capability 0 is logging hooks. Asserts the first capability in the combined collection is the logging hooks instance, verifying composition ordering. Assert combined, capabilities 1 is rate limit hooks. Verifies that the second item in Combined's capabilities list is the exact same rate limit hooks object. So the takeaway is that capability ordering and CombinedCapability give you a declarative way to nest lifecycle hooks without subclassing AbstractCapability. You declare who goes outermost and who wraps whom, pass both to CombinedCapability, and it topologically sorts them at construction time. The assertions just confirm the ordering landed right. Trade-off is you trade per method control for cleaner cross-cutting composition, logging wrapping rate limiting. For example, all resolved through ordering declarations rather than manual hook orchestration.
Hooks nest around hooks. Rate limit wraps, logging wraps logging. 3 requests collapse into